Hi, Mr. Gazda here. This is Applied Physics, Homework 20, Part 2. I'm going to do the ones I didn't do in the first part. Here we go. And I need to do number 4 on the front. So here I go. Now, again, you do need the reference table. It's the top 5. 1, 2, 3, 4, 5. Those are the formulas you are going to be using. So here we go. A metal ball is pushed off the lab table. How long does it take to hit the ground? So write down what you have. This here is going to be how far it falls. So that will be the distance. So we have that. Write that down. 1.12 meters. We know, what do we know? Something following. We know the acceleration is the constant 9.81 meters per second squared. We know the it starts from rest, okay, on the table, so that's VI, initial velocity, the starting velocity is 0. What are we trying to find is the time. T equals what? Therefore, what formula can we use? You want to look over here, okay? And you're going to use, you got to look around to the ones you're going to have those variables in it, and it's going to be this one, okay? So, therefore, we will do I'll do it right here. D equals let me see. Let me write that out. D equals VIT plus 1/2 AT squared. We know initial velocity is 0, so that's going to be 0, which is kind of nice. Plus 1/2 your 9.81 meters per second squared times T squared, which is what we're looking for. Okay, T squared. So, and then we know our distance is 1.12 meters. So what you're going to get is basically you multiply. This is going to be half times that. You want to get T squared by itself. So then you end up with 1.12 meters divided by 4.905 meters per second squared, and that's going to equal T squared. Okay, so when you solve this, what you get, and where's my, okay, let's do the numbers there. 1.12 divided by 4.905 equals this, 0.228. I'll write it like that. Now the units are going to be a bit trickier, and let's do those over here. So now you have meters over meters per second squared. Keep change flip will lead you to this. Keep the meters over 1, and you change it to that, and it's going to be second squared over meters. I'm sorry, my fault. Second squared over meters. The meters cancel out, so it's going to be second squared. Okay? Therefore, where are we? We have that. So the answer is second squared equals T squared. And so to get T, right, you do the square root of each, get just T. So the square root of second squared is going to be seconds. The square root of that is going to be 0.477. We round to 0.48. 0.48 seconds. Okay, so that's the answer here. 0.48 seconds equals T. The time would be in the air. Okay. A little bit complicated, but you know, this is basically what physics is here. So on the back, we're going to do a 5-gram golf ball is dropped off a building, hits the ground 2.5 seconds later. How tall is the building? How tall is the building? Let me get some scrap paper here. Now, 5 gram doesn't matter because the weight is not going to matter. The mass is not going to matter. Everything free falls at the same acceleration. Okay, so what do we have? We know acceleration. Anything free falling, 9.81 meters per second squared. We know, what else do we know? We know T is 2.5 seconds. We know the VI is going to be 0, and we're looking for D. D is what? Okay, so same thing, you go here and you try to figure this out. This has D but doesn't have anything else we need there. This does not have distance in it. This does not have distance in it. This does, but we don't know the final velocity. Okay, so the final velocity we don't know, but we do know VI, we do know T. And we're trying, what are we trying to find here? We're trying to find, yeah, the height of the building, which is going to be distance of fall. So here we go. So, let's see, its formula is D equals VIT plus 1/2 AT squared. So the D is what we're trying to find, distance. This is 0, which is nice, because initial velocity falling downward there is 0, plus 1/2 acceleration. It's on the front of your reference table. If you don't know, don't need to memorize it. It is right here, 9.81 meters per second squared, acceleration due to gravity. On the front of your reference table, you need it, and that is meters per second squared times t squared. I'm sorry, we know what t squared is. That's 2.5 seconds, and that's squared. So, when you do that, the 2.5 seconds squared, 2.5 times 2.5, you could use your square root function. That's going to be 6.25, and that's going to be seconds times seconds, seconds squared. And then you would do 1/2, 9.81 meters per second squared. And the numbers are going to be that times 9.81, basically times 1/2 or equals, and then divided by 2 or times 0.5, either one of those. I'm not sure how you do it. So far we have the D, the number is going to be that, 30 point, I'll call it 30 point, let's call it 30.66 for this purposes. Now the units, let's do the units, I'm going to do it on the bottom, is going to be meters squared times seconds squared. Put that over 1. Notice these are going to cancel out. Our units are going to be meters, and you always want to check, does that make sense that we measure distance in meters? And it does, okay? We measure distance in meters, and that's going to be your answer. Maybe you'd round it to 30.7. It doesn't really say what to round to, but that's okay. But always check, because if you get meters per second for distance, that's not right. If you get meters per second squared, you get seconds for distance. We don't measure distance in seconds. So that is a very good check, and you should be doing that. That is 1 on the back, and then soldiering on to number 4, a peregrine falcon goes into a free fall dive. Now this is a little weird with the bird, but just it's free fall, it's falling freely, disregard the wings and all that other stuff. After its prey for 4 seconds before hitting it on the head, what is the falcon's speed? And what that means, what is the falcon's speed right as it's hitting the prey on the head after the 4 seconds? Not the clearest question, but that is what it means. So what are we interested in here? What do we know? Free fall, we know acceleration is 9.81 meters per second squared. We know that the time here is 4 seconds. We know, I guess we got to assume the initial velocity in that dot starting there is 0 meters per second. And we're trying to find the final velocity. VF is our question mark. Which of these formulas will work here? Well, with A, T, VI, VF, that doesn't have it. That doesn't have the change. We can't figure out the change in velocity there. And we're not going to have final velocity. That, let me see. We want final velocity. We know initial velocity is 0. Acceleration times time. Yeah, so that'll work. And then this has distance. We don't know distance. So this has worked. It's the third one down. This one too, but we don't have distance again, so it has to be that third one down. And that is going to be VF equals VI plus AT. And VF is what we're after. VI is going to be 0 plus 9.81 meters per second squared times time, which is 4 seconds. And now that should give us the answer. So let's the numbers we can do. 9.81 times 4 equals 39.24. 39.24. Now let's do the units here. I'm going to do them separately here at the bottom. Meters per second squared times seconds. Okay, put the seconds over 1. Cancel out this seconds here, which is the squared. Okay, and what you're left with is going to be meters over seconds. So meters over seconds, we have VF equals 3.9.24 meters over seconds. Now I want to ask the question, does that make sense? Velocity, speed, measured in meters per second. Does that make sense to me? Is that a unit we would use for it? And the answer, hopefully, you should be saying, yes, it does make sense. And then the final velocity there is just that, meters per second. So work through these. I hope that it helps there. This is part 2, okay, of 40. I'm Mr. Gazda, and I approve of this homework.